Hey there everybody, welcome back to my channel. In this video I'm going to talk about two different types of data structures and we're going to compare these two different types of data structures. One is the array. We know that array is a linear data structure. Generally if we consider array, it's a simple data structure, right? It's the basic and it's the first data structure which we generally study whenever we study the data structures and algorithms. So array itself has a lot of advantages, but array generally has a lot of drawbacks, which is solved by a linked list. So let me just state the drawbacks that are present in array. We know that array is a linear data structures and it has its own index for all the elements, right? If suppose we're going to insert a new element into the array in the position 2, what we're going to do is we can't just insert the element just like that. What we'll be generally doing is we'll have to shift the element that's already present in the second index to the other, to the adjacent positions, so that there is a shifting that takes place, right? We have to shift the existing element to the other, to the adjacent positions in order to insert the new element in the desired index. So in this case it's fine if the array, the size of the array is small. If the size of the array is huge, it's going to be a tedious process and it's going to take a lot of time. So this is the first problem. So shifting the position becomes very difficult whenever we consider inserting the elements. And also even deletion becomes difficult. So even if we delete a specific element, we'll have to make up, or maybe we'll have to make up the array, so that the space doesn't remain empty, and we'll allocate this space to the nearby element. So secondly, the issue in array is the size of the array is fixed. So what I mean when I say the size of the array is fixed is, so whenever we declare the array, it's declared to the upper limit of it. So the upper limit is nothing but the maximum, or the maximum index or the maximum length of the array. So in this case it's the 4. So four blocks of memory is allocated to this specific array, irrespective of how many elements are present in the array. So at the time of, at the time of declaration itself, the memory is allocated. So even if we delete an element, the space gets wasted. So in that case, a lot of space is occupied at the time of instantiating the array. So whenever we declare an array and specify its size, that much of space is already allocated for this array. So we can say that the space is the upper bound of the array. The upper bound or upper limit of the array is predefined, predefined, and also allocated. So this is another drawback in array. So whenever we consider the linked list, the advantage of linked list is, or generally if we consider linked list, this is how it works. So here there'll be data, and this is the node or the pointer to the next node, right? This will have the index of the next node, and this will have the data, and this is again the data, and this is the pointer to the next node. So that is initially, head pointer will be pointing to the first node and the last will be pointing to the null. This is in consideration to a singly linked list. If there's data and a pointer, that specific structure is called as node. So this is generally what a linked list is. So the advantage of linked lists is, it doesn't actually have a predefined size that's allocated. So it's we can say that the size of linked list is dynamic. So it's really dynamic, and so whenever we add the elements, so then and thereby the elements are added. So if this is the linked list that's there, if suppose we are adding, so initially if there is only two nodes, so only two blocks of memory will be allocated for this. So whenever we are inserting the another node, so then and thereby there'll be the allocation of memory. And also whenever we consider the insertion and deletion, it's very easy in linked list. There's no need of shifting the elements, unlike in the case of arrays. So if we are gonna insert an element between these two nodes, so what I'll be doing is I'll be changing the pointer to this node, and then I'll be keeping the pointer to this node as this node. So then this connection won't be present, right? So this forms a linked list. So it's very easy when we consider insertion and also deletion. Deletion will be same way like this. Let me just talk about how memories are allocated and all of that. So whenever we consider an array, it's like whenever we insert an element, or whenever we are like inserting an element, we are like shifting the elements to the other side, or whenever we insert or delete, right? So generally how this works is, so there'll be memories that are allocated. So if a new element is added, so all of this, so this will be moved. So this is how it works in memory. So in linked list, whenever we are like adding the elements in between, what happens is, this is a node that's existing, and then we are going to add a new node into it. We're going to add a new node between them, so this will already have the memories, right? So let us say this is the first node's address, and this is the second node's address, and then let's say this is the memory that's allocated to it. If suppose we are adding a new node to it, what happens is all of this existing memory space will be shifted to another new memory space. So again, the it'll be starting from the first. Say the memory location for this element will be allocated here, and then for the next new element which we are going to insert, that will be here, allocated here, and then the third element, that will be allocated here. So unlike arrays, which has a static memory location, and then the memory locations are shifted whenever we insert and delete, in linked list we are generally creating a new space of memory, so that whenever we perform the insert and deletion operation, there is no complexity, and it doesn't require a lot of time. Now we have looked into the drawbacks of arrays and why we need linked list, because it has a dynamic size, and also it's very easy to insert and delete elements in linked list compared to arrays. Now I'll just talk about some of the disadvantages that are present in linked list. So whenever we are trying to access an element rather than inserting, so whenever I say there's a linked list like this, the head is pointing over to the first node. If this is a linked list having 50, 40, and 30, so if suppose I'm gonna search for access 40, so there's no random access that's allowed. So we'll have to traverse entirely through the linked list starting from the head node, right? So unlike in arrays, what we can do is, if we're gonna access an element that's present in a specific index, we can just access it. If suppose this is in arrays, the second element will be generally having the index 1. So if by using this we can access the element. But in linked list, we'll have to traverse throughout the entire list, so that we get the desired element and we can access it. Secondly, the drawback is, whenever we create a node for a linked list, we notice that there are two sections. One is for the data, and the other one is for the pointer to the next node. This is the pointer to the next node. So whenever we create a node, we have to create an extra memory space. We have to create an extra memory space for the pointers as well. So this is another drawback whenever create a linked list. So that is it for this video, guys. We have seen the drawbacks in array, and we have seen why we need linked list over arrays, and also we have seen the disadvantages of linked list and where the linked list fails. So thank you so much for watching this video, guys. If you like this video, please subscribe to my channel for more contents like this. And I'll see you guys in another video. Thank you. Bye bye.